ഒരു 2 മിനിറ്റ് കൂടെ വെയിറ്റ് ചെയ്യാമല്ലോ സാർ? Sir, shall we start? Others will join. Okay. Good evening, all. I welcome Professor Vishnu Nambudiri sir for today's session of Python workshop. I welcome all our participants and hope you will have a very grateful session today. And I hand over this session to Professor Vishnu Nambudiri. Thank you.
So I think the YouTube streaming sound was not there. So I'm just repeating that today's plan is to start discussing defining our own functions and making use of that. And in addition to that, we will try to consolidate the ideas so far we have discussed through more programs with mathematics background, so that as mathematicians or mathematics students or mathematics researchers, we will be able to see that how Python can be used for doing problems in mathematics. That's what our main aim is. Okay, let me start sharing my screen. Once again, I am using my spider window for writing the programs. As I told, initially we will define a program where we are going to define our own functions. Remember that yesterday we had made use of functions like the sine function. I think we have already seen how to use that. And apart from that, the maximum function and minimum function, but these two functions are not from the math library, but they are directly available with Python. So the sine function was from the math library, square root function was from the math library. These functions we used. And apart from that, we will try to see those functions were defined by somebody else and made as a part of Python library collection, Python book collection maybe. So Python libraries are usually known as Python modules, and Python modules are imported to our program, and functions in that those modules are um, made use of in our own program. So instead of that, let us see how to define our own function so that that could be used in later programs if needed. Okay. So main aim is to define functions first of all. We start a new file. Is there any question?
Yes, sir. Can I have one question from
Yes,
the
yes.
last?
Yeah.
So the last program you just shown that yesterday night, the Fibonacci sequence.
Yeah.
So that you have defined using the while loop. Is it possible to generate this Fibonacci sequence within list completion?
With list comprehension.
That Fibonacci, that list you have generated by using while loop, is it possible to generate that Fibonacci uh, Fibonacci list?
Haha, I guess so, but the only difficulty I'm finding is that you are going to call a list within that list itself. Another thing is that the variable properly you need to define. Of course, you can define the variable to be, say, I from 2 to 20 if you want to generate the first 20. And maybe you can start with 1 and 1. But afterwards, I don't exactly know that whether we can make use of the same list inside. We can refer to the same list inside the same list. For example, if you are defining a fib list is equal to say d plus 1 or di plus or di minus 1 plus di minus 2 where I from this, and then you need to define multiple conditions. These things is going to be possible is what I guess using some construct like there are certain extra tools like lambda constructor kind of thing. Using that, it's probably possible, but I have not tried that. We can try that maybe later. After some time,
Okay,
you just remind me. We can try that towards the end of this program to see these things, if
okay, sir.
possible.
Okay,
I don't
thank you.
exactly know, to be frank.
Okay, sir. Thank you.
Okay, thank you. So next program is the 20th program. So define functions. That's the aim we have. Okay, by the way, I should give you the link for the Google sheet where the code is pasted. Let me share that first. Yeah, the link is here. So let us define a function first of all. So what type of function we should define? Maybe I will show you how to define a function for finding factorial, say for example, so that we can find after defining a factorial function, maybe we can find out the binomial coefficient NCR. Okay, that's the aim we have. Define function, use it to find. So in the notation, this is binomial NR. So we need the factorial function first of all. Even though there is a factorial function available in the math library, we can just try to define our own function. So for the sake of understanding the concept. So a function in Python is defined using the keyword def. After that, you need to specify the name of the function. Since I told you already that the factorial function is already present, and if you do not exactly know that if such a function is already present, and even if you are defining a function which has already the same name function is existing in Python, your function will take precedence. Your function will take priority. Okay, your own defined function will have priority. Whatever previously defined function available in Python will be completely ignored, and your function will be taken precedence. But you cannot use keywords for defining function names. Okay, existing function names can be used for defining your own function, but you cannot use keywords for defining Python keywords like def. Um, Print can be, I think, used. Print is not a keyword. I think it's a function. You can use that. But if you use print as a function name in your own, what do you call, your own environment, your own program, the already existing print cannot be further used in your program. So such a problem can rise if you are using existing function names for your own function names. So you need to be careful. So to denote that I am defining my factorial, I just write my factorial as the function name. So factorial of n is what I'm trying to find. Just like stopping an if block or if sentence or while sentence or for sentence, end it with a colon. Now we know that the factorial is actually a product. Factorial is nothing but n factorial is nothing but 1, 2, 3, 1 into 2 into 3 into etc. into n. So we are multiplying from 1 to n. So multiplication, it's a binary operation because so we can operate multiplication only on two numbers at a time. Okay. So we need to define multiplication programming in such a way that it's acting only at two numbers at a time. So what we are going to do is a standard technique in programming that we will define initially some variable to be 1. After that, we will multiply that variable with 2 and store the value inside the same variable. Then we multiply, then the value inside the variable will become 1 into 2. Then we again multiply the variable with 3, so and store it to the same variable. Therefore, the factor that the variable which was holding the value 1 into 2 now will have value 1 into 2 into 3. Keep on doing like this up to n. That's the logic behind the program. Okay. So let me define f to be equal to 1. So whenever we are trying to multiply and keep on multiplying something, we initially define a variable to have value equal to 1, and we keep on multiplying the numbers to this particular variable and store it inside the same variable like this for I in range. So from where to where we have to multiply. One more thing is that okay, I'll come to that later. From 2 to n. So 2 to n plus 1 we need to take. 2 to n we are going to multiply. How do we multiply? F is equal to, see that there is 4 spaces left before starting this up because just to show that f is inside the function definition. 4 is also inside the function definition. Now this f, second line f, in fact the fourth line f in the program code, this is inside 4 also. Therefore 4 plus 4, 8 spaces left. Now f is equal to f star I. So what will happen initially? On the right side, the first value of I is 2. So 1 star 2 will be computed. That will be pushed back to f. I will become 3. Now f is 1 star 2. So 1 star 2 into I means 1 star 2 into 3. So that will be again pushed back to that f, and the process will keep on going like that. And there is actually a short notation. We can actually use f star equal to I. This short notation is actually equivalent to saying f is equal to f star. Okay, let us use this short notation instead. This is equivalent to saying f equal to f star. So after multiplying f with 1, f with 2, f with 3, f with 4, f with 5, etc., f with n, finally the complete multiplication is over. Now returning the value of my factorial, returning the value of f, not my factorial, return f. Can be in bracket, not necessarily. See that after typing this return command, when I am pressing the enter key, the control is automatically going towards the left margin. Okay. Now let us try to make use of this function. Suppose n is equal to 5. We are trying to find NCR. Maybe we can even print how to use this, just like we use any function in any important function, any function in mathematics. My factorial of 5. We are trying to see what exactly this is. Okay, let us try to see this. Oh, I haven't saved. I'll put it as factorial function. Saving. Saved. Running. So the answer is 120. So 5 into 4, 20, 3, 60, 2, 120. That's correct. Now, say R is equal to 2. So we will simply put C R NCR equal to. So how do we find it? Inside format, N R, and what is the definition? The NCR definition is that n factorial by n minus r factorial into r factorial. So my factorial n by my factorial n minus r star my factorial r. So this is not necessary. If you want, you can use it. Running. This is equal to 10.0. I think because the decision is because this division is involved 10.0. Why did that 10.0 come? I don't know. Maybe because during the division it might have converted integer into floating point number. I don't exactly know what might have happened there. So anyway, the answer is correct. Answer seems to be correct because 5C2 is nothing but 5 into 4 by 1 into 2. We know. Therefore, the answer is correct. So this is how we define the factorial function and make use of it. So DEF is the keyword that we have to use for defining the function. Let me copy this to. I have copied this to Google Sheet. You may try now. That's it. Okay, I think this program is clear. What type of other function we should define? Let us try to define one more function the same way. So let us try to find um, let us try to write a function to check if a given number is a prime or not. Okay. Fine. Let's try to do that. Now, another program. The program is check primes or check primality. Okay, an n is given. How do we check if this number is a prime or not? That's the very first thing. So, for checking if a number is a prime or not, what we have to essentially do is to check if some number in the range 2 to that number minus 1 or 2 to n minus 1 divides n or not. If any number between, okay, the problem is that the 2 itself, you need to be really careful about that. So, okay, 2 to n minus 1, then if you are taking the range 2 to n minus 1, if n is 2 itself, then 2 to 1, there will not be anything. So, I think that can be actually taken care of. Suppose that n is a large number for the time being, so that we need to just check if any number within the range 2 to n minus 1 divides this number or not. But actually, even that is not necessary. For checking if a number is a prime or not, it's enough to check uh, any number in the range 2 to square root of n divides n or not. Okay, that's it. If any number in the range 2 to square root of n divides n or not, that's the primality. That's actually the best result that we can have. 2 to, of course, there are several other techniques or equivalent, not equivalent, efficient or intelligent, what they call conditions for checking primality, but for the time being, we are going to make use of the condition that a number is a prime provided that no number in the range 2 to square root of that number divides n. Okay, that's the logic we are going to use. No number in the range 2 to, okay. So definitely we need to take numbers from 2 to square root of n. So let us take the stop to be, we need only, okay, we need to, from math, import the square root function. So till where we have to search? We have to search till square root of n. But remember that the divisibility can be actually used only on integers. So square root of n can be something like what do you call a floating number. So you need to make use of, I think, the floor function. That is the integer just below that the square root. Let us try to see the effect of that. Maybe we can use 101 to see the effect, to understand clearly what's happening. Okay, 10 is a number. Because when you try to do the divisibility, the percentage operator, if you're trying to use, the arguments must be integers. If you use real numbers, that's not going to work. For example, suppose that you are using 5 percentage 2.0. Oh, that's working anyway. I was thinking that will not work. Okay, let me try. Will this work? What is probably happening here? It's taking the model even still. Is it dividing it with that number? I think it's simple division. Okay, let us try to see that. Oh, it's not okay. Not even divide. So what exactly might be happening here? So what I think is that it's probably taking it's taking 2.1. If you take 2.1 two times, what will happen? Let us try to see what exactly is going on here. So 2.15 minus 2 times 2.1. What will happen? I think okay. The same way this 2.1 is also working. There is no problem. So 2.1, it's trying to take maximum number of 2.1s from 5. So 2 times we can take out 2.1s from 5, and the remaining thing it's taking to be equal to. So exactly the same thing even here going on. But let us try to be safe enough. I think it's better not to use. I think better to use floor itself so that we can convert this into. See, another problem probably is that if there is a kind of okay here, definitely we have to make use of. Here definitely we have to make use of. Otherwise, the result will be unexpected things. So if we are using if we are using modulo operator on a floating point number, depending on the system, the result may vary slightly. So you cannot be exactly sure about what exactly the output is, or the output is going to be correct or not. Anyway, for the time being, to avoid such difficulties, such confusions, we are converting the square root of into nearest integer. Okay, just take that. Now, so for from where to where we have to check D in range 2 to stop. So what should we do? If what is the thing that we have to do? If D divides n, means if D percentage n equal to 0, what we should print? Print not a prime, because this divides it. So we will stop here by displaying the values of n and d. That's it. So that's it. Now, if this doesn't happen, and in such a case, we need to break the loop. So we need to stop. Okay, because otherwise the problem is that it will go to check the next number also. For checking if it's a prime or not, it's enough that one number in this range divides it. So after finding one number dividing it, we should stop. So we should break the loop. We are breaking the loop. So after checking all the numbers, even if after checking all the numbers, nothing is happening inside the loop, then okay. So we need to. So what is the next step that we have to write? We have to write. Suppose that d percentage n is not becoming d percentage n is becoming 0, and it comes out of the loop. Suppose that d percentage n is not becoming 0, then what should we do? Any suggestion? Suppose that d percentage n is not becoming equal to 0. So what should we do?
Sir, is it d percent n or n% d?
Sorry?
The d will come first. Is it d percent n or n% d?
Sorry. It's n. That's a mistake. Correct. Thank you.
So what is your next question? I could not
So the question is that if n percentage d becomes equal to 0, it will be printed as it's not a prime. Divides it.
Okay.
So where should we make the statement that it is a prime? How do we determine if it's a prime? Where should we put the statement that it is a prime?
If d is equals to stop.
So if no d divides, but how do we check that? If no d divides n or not?
Means if the can we take the last d value? Can we check that if the d last value is equals to stop minus 1?
So if the last number is dividing, then suppose that we are taking square of a prime, for example, 49. So in the case of a 49, actually 7 only divides it.
Right.
So at 7 only it will break. So there is no point in breaking because it has already reached 7. Okay, so in such a scenario, either we need to carefully handle this situation. See, I hope that you understood exactly what I said. The problem now is that suppose that, for example, the number that we have given is 49. In the case of 49, we are checking numbers from the range 2 to 7. Okay, so it has checked all the numbers from 2 to 7, and only at the point 7 we are getting an answer that it's not a prime. So checking that up to that particular point, no division has taken place is not enough. We need to check if no division has taken place or not.
Right.
No division has taken place or not, including up to 7. Okay, so found, we are going to make something like a flag. So something like a variable where we are going to save the information that divisor has been found or not. Found divisor. So initially when we are starting, we haven't found any divisor. So let us keep this to be false. Okay. So found divisor, we are keeping a variable in which we are storing the value false. Now, suppose that a divisor is found. At that point of time, we will turn this divisor, found divisor, to be true. That's true. So even after checking from 2 to square root of that number, found divisor is still false. That it simply means that the number is a prime because no divisor is there in the range 2 to square root of that number. Fine. If so, we need to again check if found divisor is, so here we need to check once again equal to found divisor is false. What should we print? It is a prime. Let's try to see 49 itself. '49 is the prime. Say, oh, what's happening? Stop plus 1 we should use, right? Okay, sorry. Stop plus 1 because we need a 7 also. Root of that also we require. 49 is not a prime. 7 divides it. 19 is a prime. 21 is not a prime. 23 is a prime. 29, 31, fine. Is it okay? Let me update the Google document with this. So update. So such a kind of variable which we are keeping for storing some information which we are going to use later. This is known as a flag. Okay, this is known as a flag. That's a technical, I think it's a computer programming language related word. So we are either mentioning that something has happened or something hasn't happened. It's a flag. By observing, just by looking at the flag, we'll be able to make out something. So found divisor is a flag. It's a variable, of course. So the variable we are using, provided that we are entering inside this if n percentage d is equal to 0, we are turning it to true so that we can understand that we have entered inside this. Okay, now we can construct, we can make use of, we can define this as a prime, we can define this as a function and try to find all the primes within certain range. Even though that the function that, even though the program that we are going to define is not that efficient as far as the speed is concerned, because that is not actually the best way to define a prime checking function for a range. Even though for understanding the concept, we can probably do that. So let me define this prime checking program as a function and try to do this within the range, certain range. Check primes in a range. This is what we are trying to do. So this part entirely, we are going to make use of here. Let us define a function here. Check if prime. That's a function name that we are giving. N. So how do we check? We need both these things. We need to import both these. We need this also. This also. Here we need not actually print, but instead of that, we need to return the value. No need to even break, because once the return statement is appearing, automatically the control will go out of this check prime block, check if prime block. Return. What should be returned? Found check if prime. So what should be returned? If it's a prime, we will say true. Return true. Otherwise, we will return false, because the answer is check if prime. So check if prime 21. The answer is true or false. If a divisor is found, then check if prime. It is not a prime. Sorry, that's wrong. So this is the logic we have. Now, see that what is the logic we have? Found divisor is false initially. For d in the range 2 to stop plus 1, we are again checking n percentage d is equal to 0 or not. If n percentage d is equal to 0, even this is not necessary, because we are actually stopping at this particular point. Found divisor. We have found the divisor, therefore we are returning that. If n is a prime, the question is n is a prime or not. The answer is no, false. If n is a prime, false. If n is a prime, true. True means it's a prime. So here we need to return true. Okay, let us do it inside a loop. So let us use this function inside a loop. For let's try to find primes in the range up to 100 for m in range up to n plus 1. So up to n plus 1 means that from 0 to n plus 1. So since 0 is not required, let us start from 1. Maybe even from 2. But on 2, how is it going to work? Let us see. If check if prime m equal to true, print. Okay, let us see it in action. Or else we can print okay, let us see it. Seems to be correct. So this is the function for checking if a given number is a prime or not. So let me update the Google document with this. So the Google document is updated. You may try. Okay, this is okay. We can actually use this for finding primes in a certain range also, because for that we need to modify it slightly. You need to simply change this 2. If you want to check primes in one particular range, you need to just check from that particular number to n plus 1. You can define the range here if you want. So this program can be used for finding primes in some other range. And now, if you want to push everything to a prime list, that also can be done. So maybe you can modify it slightly. Prime list is empty and composite list is empty. Maybe you can push these things. So you can even do like this. Prime list append m, and on the other hand, instead of printing, you may append to the composite list, and then you can ask for printing the list. So prime list is here 2, 3, 5, 7, 11, 13, 17, 19, etc. And the composites are 4, 6, etc. So this also can be done. If you want to the list to be shown as the set of numbers to be shown as a list. I have updated the Google document with this new version. Yeah, Aparna, is there any question? I think no. Aparna Balan, is there any question? Okay. So this program is for finding primes. Okay, and let us try to do some other thing. So using this particular program, okay, now let us try to find out, let us try to do some abstract algebra in which we, especially in the case of, I think, discrete mathematics, we need to find out, we need to check the set of all units in Zn. Okay, Zn means the congruence class is modulo n, starting from 0, 1, 2, etc., 2, ending with n minus 1. So the set of all units means that we are trying to find out all the elements that are relatively, all the numbers in the range 0 to n minus 1 that are relatively prime to n. Okay, relatively prime means that GCD equal to 1. So we will put an m into the set of all units modulo n, provided that GCD of mn is 1. So already there is a GCD function in the math library. Let us try to make use of that, and let us try to prepare the list of units in Z. Okay, that's a problem. That's not involved in functions, not necessary to involve functions. We are simply going to make use of the existing GCD function in Python math library. So this is just to make sure that we have enough experience in writing programs. Okay, so we will not be able to write programs unless we have experience in writing more and more programs. If we are used to writing programs, used to the programming logic, we will be able to identify that how to frame our method so that it will fit into the Python framework. So 23rd program, find units in Zn. Saving it. So let us put some n here, n equal to say 25. So let us import the GCD function first of all. Import GCD, oh sorry, from math. The structure of importing one single function from library is from which library import what function. That's the structure. So if you are importing the whole library, then import that library name. That's it. So what are the units? So let us call the set of all units to be un, or simply un. So initially this is empty. So we can keep on appending. So what is it we have to check? 4, A in range from where to where we have to check 0 up to n minus 1. N minus 1 is not necessary right here because by default the range will be considering only up to n minus 1. If GCD of A M equal to 1, so what should we do? We should push this to A. That's it. Units in Z, maybe we can is, so N is here, now UN is here, and done. Is it 25? The units are 1, 3, 7, 9, 11, 13. Is it 25? Okay, what's happening to 12? What is this M? Oh, this is N, sorry. 1, 2, 3, 4, 6, 7, 8, 9, 11, 12. Let me update the Google document with this. Then you can try. Yeah, Krishna Shu, please.
So in this program, that range is starting from 0, why not from 1? And can we start from 1 to n?
Yeah, you can use even, so in this particular program,
Yes, sir.
yeah, 1 is also fine, no problem, because 0 is anyway not going to give the GCD to be equal to 1. Doesn't matter. So fine.
Okay. Okay.
Anyway, 0, even if we are putting 0, 0 will be completely, because we want to see all the numbers in the range 0 to n minus 1 and check if the GCD is 1 or not. So without exception. So if we are removing 0, then we are actually making an extra test in our own that the GCD is 1 or not. Okay. So that's why I simply wanted to just put that so that that also will be tested.
Okay.
There is no difference. If you put 0 or if it doesn't put 0, result is outcome is going to be exactly the same.
Because the GCD won't be 1.
Yeah, GZ is going to be all 0 and then GZ is going to be equal to n always. That doesn't matter anyway. So you can put 0 also. 0 or 1. Okay, now this is about a little bit of group theory. Now, the next problem, let us try to extend it slightly. So, here we have the unit group, UN is here. Now, how do we find out all the generators of UN? Is there any way to find out the generators of UN? Possibly. If it's a cyclic group, definitely generators will be there. So if UN is cyclic, then we can try to find out generators. So generate by generator, remember that we simply mean an element in UN is a generator provided that that element has exactly the same cardinality as that of UN. Okay, generator and this is a finite group. So generator and the group will have the same cardinality. What I meant by cardinality, sorry, what I wanted to say is order, not cardinality. I'm sorry, I missed that word. So the order of the generator will be equal to the cardinality of UN. Okay, that's the condition for generator. So how do we check that if something is a generator or not? Let's try to even do that. Remember that it is not necessary that UN is going to be cyclic. So generator will be there provided that it's cyclic. Okay, it's not necessary. I don't really think that there is any result saying that UN is going to be cyclic, and it can be non-cyclic also. It's certainly cyclic, of course, but UN. I'm saying about UN. Okay, let us try to see that. So how do we find generator? Now we have UN there completely. So to check if UN is cyclic or not, and to find out the generators, let us try to form the generators list. Generators is equal to this. Now, how do we find out the generators? We need to loop through all the elements in UN for G in or B in or A in UN. What should we try? So we know the cardinality of UN. Cardinality is length of UN. So what is it we have to check? So what is it we have to check? When do we say that the order of the element is equal to the cardinality? So remember that there is actually one small problem, that if you are raising this number, if you are raising the number, if you are raising the number to the power of this what do you call? You are doing all these things modulo n. That you need to remember. You are doing all these things modulo n. So if you are raising a number to, if you are raising one element from UN to the cardinality of UN, you are definitely, and taking modulo n, you are definitely going to get the answer to be equal to 1. So to check the order of that particular element is equal to the cardinality or not, we should make sure that that element raised to any power less than the cardinality is not becoming equal to 1. Okay. So an element in UN is a generator. So what are the two conditions that we have to check? Provided there is only one condition to check. It is a to the power. A to the power some s is not 1 modulo n if s is less than cardinality of UN. So do you agree with this condition?
Yes, sir.
So I am breaking this comment into two lines so that you can read it. So an element, so these are the two lines. An element in UN is below n if s is less than the cardinality of UN. Okay, that's the condition that we have to check. So now we are not just doing Python; we are actually trying to learn, trying to understand something in mathematics also. So this is why see, we have to actually make use of Python for doing something seriously. Otherwise, the programming language is going to become just dull, because there is nothing. If there is nothing serious to do in programming, you will simply forget the programming approach, programming logic, programming techniques, all these things. You should try to do some problems in mathematics. If you are interested in doing mathematics, if you are trying to learn mathematics, if you are trying to learn Python, and you are from a mathematics background, the best thing is to try to do some mathematics using Python. So, what is it that we have to check? So we have to try to find a to the power a in un. We have to try to how much time we have, how many times we have to check the power of a. So we need to take the power of a to the power 1, a to the power 2, etc. up to a to the power cardinality of -1, cardinality -1. As in the case of prime, if it's becoming 1 before the cardinality, then it's not a generator, we drop it. If it's not becoming equal to 1, even after taking up to t -1, then definitely up to cardinality -1, we definitely know that a to the power cardinality is anyway going to be equal to 1. So we don't have to check that. So we will mark it to be the generator. So the checking is from 1 to cardinality -1. So there are two loops for P for or yes, for yes in range 1 to cardinality. So 1 to cardinality -1 will be checked. If what happens? If a to the power yes, then we need to take modulo, right? Percentage n equal to 1. Then what should we do? Then we need not check for any other s. We should put a flag to mark that it's not a generator. But instead of that, there is actually another feature in Python, which can be, this is actually possible only in Python, that using else along with for. We need not check. Once you found a to the power s to be equal to 1 modulo n, we need not go further. So if the break is not happening, means that we tried from 1 to cardinality -1, even after that we are not finding it to be equal to 1 modulo n. That means the break is not happening. Then it's a generator. So we can use else together with for. This else is not together with if, else is together with for. When this will run? This will run provided that this break is not met. That means the complete loop, if the complete loop is exhausted, without breaking, without leaving any value, then this else will happen. Else, let us push this a to n. That's it. Finally, print generatives. Let's try to start with 4. Or 5. 1, 2, 3, 4. 2 square is 4. 2 cube is 8, which modulo 5 is 3. 2 raised to 4 is 16. Modulo 5, it's 1. So correct. 6. So only one generator. 7, it's a prime, so UN is definitely cyclic. 8, no generators. So U8 is not cyclic. Let me update the Google document with this. So when I am copying and pasting the code to the Google document, sometimes the spacing formatting is lost. You need to be really careful. So you need to check if the formatting, the spacing is correct or not. Otherwise, everything is perfect. And sometimes the initial letters are becoming capitalized. That also you need to check if you are copying and pasting. Maybe we can make it a little bit more friendly, saying that if there are no generators, we can even say that. We can simply print that. So 1357 has no generators. So the last two lines I'm modifying. In fact, the last line. So if there are no generators, even simply print that. That's it. So do you have some question? Hello, can you please, I think, Sindhu, can you please mute yourself? Hello? So I hope that this is fine. This program is fine. Now let us move to something else. So this was something related to group theory, and so even elementary group theory questions can be actually solved in this way. Of course, more and more things can be done in group theory, provided that we know the symbolic mathematics thing. If we after trying to learn, we can probably do more problems in group theory. Not now. So let us try to do one more problem using while loop, because we have used while loop only for I think one problem so far. So the problem is about converting numbers from one base to another. Okay. So how do we convert a number from one base to another? For converting a number from one base to another, for example, suppose that we have a base 10 number. How do we convert that base 10 number to base 2? So for converting that, we need to divide the number with 2, keeping on dividing with that number with 2. Take the remainder. Okay, keep on taking the remainder, and whatever is left out, then see. Uh, the remainder will be put into a list. So what we have to do is the remainder we need to subtract. Okay, remainder we need to subtract. For example, suppose that we are trying to convert 101. Suppose that we are trying to convert 101 to base 2. So in that case, we will try to we divide with 101 with 2. So dividing in the sense that finding the remainder. So 101 percentage 2 is equal to 1. So 1 is now subtracted from 101. So it will become 100. Okay, what is next after that? So let's try to do that first. I will show you doing one problem ourselves. If we are able to do the problem in ourselves, then only we will be able to convince the compiler, or then only we will be able to make the Python interpreter understand what exactly we want to do, what exactly we are trying to do. So let us try to see an example first. A new file. So the problem is conversion from one number base to another. So for example, suppose that we are trying to convert 10. The problem is now convert 10 base 10 to base 2 number. So how do we do that? Or maybe 11. Let's take this to be 11. So how do we do that? We need to take 11 divided by 2, 11 percentage 2. And that is equal to 1. So what next after that?
Then 5 by 2.
So 10 is now left, right? 11 minus 1, that's 10. What next after that?
Then sir, 10 by 2, that
10
is
by
5.
2,
So
10 by
5.
2. The remainder is not there. So 10 by 2, that will give 5. What next? 5 percentage 2, right? So 1. So 5 minus 1 is now 4. 4 by 2. Yeah, this is equal to 2. Now 2 percentage 2 equal to 0. There is no more remainder. So that's it. So what is the final output? What is the final number that we have to take? Is it? Shall we put like 1? What is the next number? We need 11. So 1 is there. Next remainder is 1. Next remainder is 0. Is it 1 1 0? Is it is correct? No, it's not correct.
No. 1 0, then 1 1.
From where that 0 is coming?
Just previous left. Means two.
No.
Line number 18.
Have we done at line number what?
Sir, line number 18. That remainder.
No, in which order we are writing it then?
And then it's opposite way. That from.
So if you are writing, then it's 0 1 1.
Okay.
This is 0.
The question should be in the second side. Right?
This is 1. Just 1 second. What is a mistake? So we need to subtract the remainder. Remainder is subtracted. Number becomes less than the base. So what is 110? What is 110 will be it will be nothing but 110. So 0 into 2 to the power 0, 1 into 2 to the power 1 into 2 to the power 1, that's 2. So 1 into 2 to the power 2, that's 4. That's 4 plus 2, that will become 8. So something we are missing here. Just 1 second. So we have 15 by 2. So from the last point onwards, we need to write. So we need to take it in the reverse order. So the last number is here 0, but not 0. Okay. Is it just 1 second? Something is missing. So 11 percentage 2 is 1. That's correct. Remainder is correct. So 1 is removed. Therefore it's 10. So it's becoming 5. 5 percentage 2 is now 1. Now it's 4. Okay, 4 percentage 2. Okay, we need to do that probably. 4 percentage 2 is no. 4 here after removing the remainder we are dividing with 2. 4 percentage 4 by 2 is 2. That's done. So 2 by 2 is now 0. But 11 is how much in base 10? 11 is how much in base 2? 1, 1. So 2, 0, 1. Is this correct? No, 1, 0, 1, 1, right?
1 0 1 1.
Yes, sir.
1 0 1 0 1 1 or 1 0. Okay, 2 needs to be there. So here 1 0 1 1 is required. So what is missing here from this? What is missing from this particular procedure? 11 percentage 2 we have taken to be 1. So 11 minus 1 we have taken to be 10. Now 10 is divided with 2, that's taken to be 5. 5 again taken with this 2, so we are getting 1. So 5 minus 1 is 4. 4 is again divided, we are getting 2. So 2 percentage 2 is 0.
And another that question we have got last one, that one.
Which one?
That means after that 18 step, one more step is required. That is 1 we have got as a question. So 1 put there.
I didn't understand what exactly you are saying, because 2 percentage 2 is already 0. So are you saying that we need to subtract? Okay, what you are saying is maybe 2 minus 0 need I take the remainder? Okay, let me just try. Let us try to see the explanation after that. So if you are trying to do this, then 2 by 2, then in that case you need to take 2 by 2. You will get 1. Okay, this is probably there is no, yeah, that's right, because unless it becomes less than or equal to, we need to keep on dividing. Okay. Okay, 2 is not less than or equal to. Okay, I think that's the reason that that's what the mistake we made. So 2 minus 0, then 1 percentage 2. We need to take only remainder. This is 1. So this is like this. So 1, 0, 1, 1. Correct. So let us try to make use of this procedure. I'm commenting out. So let us take the base first. I don't know base is a keyword or not. I think no. I think no. So let us take the base to be equal to 2. N to be equal to the same number, 11. So base 2 n. Let us keep it as a list for the time being. After that, we can club the list together and we can show it. So base 2 is now base 2n is a list now. So from where onwards we need to what are the steps that we have performed for from where to where we have to do all these things until the remainder until the remainder becomes less than 2, right? Until the remainder becomes less than 2 or not the remainder, what we have to check, what we are essentially checking. This is 11 percentage 2. Okay, let us let us use n itself. N is greater than or equal to the base. Let us try to see if we are doing it exactly correct way. Let's try to see after writing the complete code. N is greater than or equal to base. What is the procedure that we have to adapt? We should remove the remainder from n. That's what essentially we are doing. Remove the remainder, find the remainder, push the remainder to the base to n and remove the remainder. Okay, so let us push the remainder base to n. We are pushing the remainder n percentage base. After that, remove the remainder base. No, after that, n from n, remove the remainder. What is the remainder? The remainder is here. So the remainder is therefore removed. N this expression n minus equal to n percentage base is equivalent to saying that n is equal to n minus n percentage base. Now, what is the next step after that? N we should divide with what? With the base. So n should become equal to n by 2. Okay, n should become equal to n by 2. So here, let us try to execute these steps in ourselves. So initially, n is greater than or equal to base. So what is the base here? Base is 2. This is 11. 11 is greater than or equal to 2. Therefore, to this empty list, n percentage base. N percentage base is 11 percentage 2, which is 1. 1 will be appended. So now base to n, here 1 will be there. After that, what's happening? N is becoming n minus n percentage base. N percentage base is now 1. So n becomes 10. After that, n is divided with base. So n by 2, which is 5. Okay, now 5 is still greater than or equal to base. Therefore, again 5 percentage 2 will be appended. So from 5 percentage 2, that's 1 will be removed. So it will become equal to 4. It will continue like that. Okay, let us see the final output here. Base to n or base converted. Okay, that's better because it's not going to be 2 all the times. Base converted n. So the program name is 24 base conversion. Let's see it. There are two things that we need to take care of. One is that n percentage base. N percentage base is now getting converted to a float number which we don't actually want. So convert it to int. That's the first thing. But the next thing is that only 110 is getting appended. So until the remainder becomes 0, we need to do that. Okay. While n is greater than, let us try to do this. Not until it becomes equal to 0, until the remainder becomes equal to, until this becomes equal to 0, let us try to see this. Let us try one more example. 11 to base 8. How much this will be? How much is 11 to base 8? 8 and 3, right? No, sorry. 11 to base 8 is nothing but 1 and 3. Not 8 and 3. 1 and 3. Sorry. Uh, 3, 1. We need to probably reverse it, right? So 3, 1.
Yes.
So let us reverse it.
அதான் ரெண்டு நாளைக்கு இருக்கீங்க.
அது பிரச்சனை இல்லை சார்.
ரெகுலர் ஸ்டாக் வந்துட்டு தான் இருப்பாங்க.
So let us reverse.
இப்படியே வந்து சார்
So
உங்களுக்கு
hello, can you please mute?
வந்துட்டு தான் இருக்காங்க சார்.
Yuva Raj, can you please?
நாலு காலேஜ் தான் சார். உங்க
Hello.
பிகே இருக்கு சார். காலேஸ்வரிங்க.
Hello.
நேரு காலேஜ். இப்போ பொங்கு முடிஞ்ச இடத்துல நெக்ஸ்ட் வீக்லயே பிகே இருக்கான்னு நினைக்கிறேன் சார். அது வந்தாங்கன்னா இந்த செமஸ்டர் முடிஞ்சிடும் சார். இப்போ அடுத்த செமஸ்டர்ல அவங்க காலேஸ்வரி பிகே இருக்காங்க. செமஸ்டர் கண்ட ஈவென்ட் மாதிரி வச்சிருக்காங்க சார். ஹலோ ஹலோ
Hello sir, can you please mute?
சரி சரி சார். ஹலோ டேரக்டர் சார். எஸ் சார் பொறுத்த வரைக்கும்.
Sir, I think you can mute him. I think sir, Anil Kumar sir, you can mute him. I think from your side because you are the host. Okay, thank you.
Yeah, I done that.
So we need to reverse the list. Reverse. Why reverse is not working? Did I do it like this? Oh, what is this? Reverse. Why it's not working? Reverse. Is the spelling correct? R-E-V-E-R. Oh, V-E-R-E-S-T. Okay. No. I wrote it correctly only. Name reverse is not defined. Where are we using this? Base converted n. Print. Sorry. 1 minute. I should probably do it like this. Reverse first, then print it. Okay, now it's fine. Base is 2. Is this correct? 1011.
Yes.
Now, how do I show this as a number? If I want to show this as a number, maybe I can append this as a string, or I can just uh, so instead of doing all these things, maybe I can straight away define an empty list instead of define an empty string instead of this, and maybe I can do like this. Um, okay, then in that case, reverse is it going to work? I don't know. Okay, let me just try to do that once again in some other way. Converted n to string. Let me convert this to a string first. Or otherwise, what I can do is I can define an empty kind of thing and keep on adding. So for digit in this, let me just try to add to this equal to string, converted to string d. And let me try to print this. So converting the string and then printing. So 101. I think that's one way. Maybe there are several other ways also. I don't exactly know. So what I did here is I defined an empty string here, a string without any content in that. Now take out every element, every digit in this base converted in. Now to this empty string, I'm keeping on adding each and every digit as a string. So string addition essentially means that string addition simply means that I'm appending each and every digit to this and finally forming a single string. That's why the result is appearing like this. So converted to base is, so what are the things? The n is here, base is here, and base converted string is here. Oh, what is 00? What is your n? Now there is a problem that we were keeping on modifying this n, right? We were keeping on modifying this n, and therefore the previous value of n is lost. So let us keep this value of n copy, because we are keeping on changing, modifying this n. That's why the value of n is actually lost. So preserve a copy somewhere here. So that's it. Let me update the Google document with this. Somewhat a long program, but I think quite useful. So I will suggest you an exercise that try to write a program which will convert from any base to base 10. And one more exercise probably is that okay, that will be a little bit more difficult. Conversion from one base to another arbitrary base. So conversion from 2 to 8. So for conversion, usually whenever we try to convert, what we usually do is that we will bring the base 10 in between. The intermediate base we will be using as 10, so that all the conversions are from 1 base to 10 or 2 base 10. So one exercise is try to convert from one base which is given as a string, because usually in Python all the numbers are assumed to be in base 10. So there is no way to give any number in base what you call base any other base. Probably if you are putting 0 in the beginning of a number, I think it will be treated as base. 0 means base. Okay, let us try to see that. Print 0, 11. What is this? Okay, 0O, that's octal. I don't know what is 0B. Is it binary? Yeah. So the binary representation is 0B in Python. So 0B means that 1 is the number in base binary. I don't know whether you can use 02 here instead. I don't think so. No. 0O for octal. Maybe 0H for hexa. No, H is not working. 0X. 0X is for hexa. So if you want to give a number in base 2, maybe you can enter it as a string. Later, split out all the parts in that string, convert it to integer, then try to convert it back to decimal, sum all those things, and find out the final number. Okay. So an exercise probably I would like you to try is write a program to convert from base 2. For example, you can try with 2. The program is going to be more or less the same with base 8. There is not much difference. 2 is 10. That's an exercise. You may try to do that. So this question is also updated in the Google document. So good, we have done something seriously. So the conversion should not be really difficult, maybe. Conversion from this to that should not be very difficult. Okay. Now let us try to do one more problem before stopping. I think one more problem can be done. We have already had sufficient number of examples from various places. If you would like to try some other, if you have anything in your mind and if you can try it together, I can try that. Otherwise, I wanted to actually try something like, so I had in my mind trying something like finding sum of two matrices. Of course, product of matrices is also there, some of the matrices, but some of the matrices actually can be, once we are introduced to the numerical Python library, we can quickly and easily do that. There is no need to spend too much of time for that. So maybe, but some to what do you call it, to make sure that we have enough understanding about Python logic, we can try to find out some other problem where we can apply some logic. Okay. So arithmetic mean and all these things we have already tried. There is nothing to try because already we have seen that arithmetic mean can be found by taking that maximum of the numbers and after that taking sum of the numbers and after that taking sum of numbers by length of the list. That's more than enough. Okay, let us try to do one more problem. That is about finding a norm of a partition. Okay, one more problem I can think of is finding norm of a partition. Another problem is also there. I will try to even do that. Try to even discuss that. So, okay, finding norm of a partition. How do we find the norm of a partition? Norm of a partition, partition by what I exactly mean is, suppose that we have an interval, closed interval. Suppose that we have a closed interval AB. By partition of the closed interval, we simply mean an ordered set of numbers x1, x2, etc., xn, where x1 is equal to a, xn is equal to b. So that's a partition, and x1 less than, x2 less than, etc., up to xn. And norm of the partition simply means that length of the largest subinterval that can be formed using xi and xi plus 1. Okay, that's a problem. Let us try to see that. And after that, there is one more problem I would like to try. So this problem is finding norm of an interval partition. So the logic is AB closed interval x1 a equal to x1 less than x2 less than, etc., less than xn equal to b. Okay, the feedback link, let me post to the YouTube streaming also. So we need to find maximum of, this is very easy, maximum of x I plus 1 minus x I. Okay, this is what norm is. Okay, let us start with some AB. Let us try to define a partition itself directly. Partition. Suppose that we are partitioning 0 and 2. 0, 1.1, yeah. Krishnashu, is there any question?
Yes, sir. So can you just say what is the norm of this partition we have defined?
That's what I'm saying. Length of the largest subinterval.
Length of the largest.
Yeah, you need to take consecutive points. You have to take, find out the lengths, find out the maximum length. That's it.
Means the length of consecutive 2 points.
Sorry?
Is it the length of consecutive 2 points, like x2 minus x1 or x3 minus
Yes,
x2?
yes, consecutive. So if the partition is usually given as a set, and you need to arrange it in the increasing order first of all.
Okay.
So the elements have to be in the increasing order, because then only we will be able to take consecutive. That's necessary. So if it is not in the order properly, 0.5, 2.2 is not there, because partition of, suppose we are taking 0 to 2, 1.2, 0, 0.5, 0.6, some randomly I am choosing some numbers so that we can sort it out. 0.67, 1.57, 1.9, something like that I'm putting. Okay. So this is the partition that I have. How I separated everything with, what's the problem here? 1.0, 1.1, 0.5, 2, 1.2, comma. Sorry. I think that's it. Now let us sort it. Remember that if you apply the sort method, partition will be sorted. If you apply sorted of partition, the partition itself will not be sorted. Then you need to save this sorted partition to some other variable. Use that variable. Here, the actual variable itself will get modified. So partition sort. Sort in ascending order. Try to see it in printing. So let us give the name to be. This is the 20. What is this? 25th program. Okay. So partition norm. That's the problem name. So print the partition. 0, 0.5, 0.5 is appearing once again. Let us remove that. 1.3, let us put. Okay. So what is next? Now let us take the lengths. How do we take the lengths? So we need to find how many elements are here. Okay. So we can use list comprehension, and after that we can find the maximum of that. 4. So we need to find xi plus 1 minus xi. Four. Okay, therefore we are in a kind of trouble. Xi plus 1. This we cannot. How do we do this? So instead of that, can we use this technique? Yeah. 4 I in range. So from where to where we have to make use of. So I is starting element is 0. So 0 definitely there must be, and last element is going to be the length of that is not. So we need to check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the last element is 10. So I should, because we need to take I plus 1, I plus 1 should be 9. Okay, I plus 1 should be 9. So I should be 8. So total there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay, sorry. So last element is 9. So we need to go up to I plus 1 equal to 9. Okay, I plus 1 is equal to 9. So I we need to take up to 8. Length of partition not minus 1 but minus 2. This is correct? I think so. Let's try to see the lengths also. So what is it initially? It should be 0.5 minus 0, which is 0.5. 0.6 minus 0.5, which is 0.1, but it's given as an approximation kind of thing. Floating point arithmetic is always troublesome. Now 0.67 minus 0.6 is okay. This seems to be perfect. So we need to find the maximum. That's it. We have already sorted it. Doesn't matter. That's okay. Is
Sir, I think there will be another point, right?
one more is required.
Yes, the last point, that is
1.9 minus 1.5. 1.9 minus 1.57 is how much?
that is point 1. I think.
Just 1 second. Let us see. No. Last element is 2 and 1.9, right? 2 and 1.9 and 1.9 and 1. So we need to take it up to length minus 1.
I think so.
You see that? Oh, we haven't printed. Okay, let us print it finally. Is okay. Let us print the lengths also once again. Ah, that's correct. 2 minus 1.9 is included now. Okay, fine. Thank you. So, norm of the partition is partition maximum of the lengths. Uh, partition a norm format partition is already here. Is the maximum function in math library? Okay, let us see that. No, it's around here. Maximum of lengths. Oh, one more bracket is there. Okay, the print bracket is there. Okay, 0.5. Is this correct? 0.5. Okay, must be correct. We are not printing this lengths. The lengths lengths are I think yes, 0.5 is the initial one. That's the no. Subinterval lengths are here and norm is here. So this is how we find norm of the partition. So let me update the Google Sheet with this. So that I think we will stop with this problem. We had done, I think, a few problems using almost all kinds of ideas that we have so far discussed. So I think as per the schedule, tomorrow we are supposed to discuss what? Tomorrow we are supposed to discuss something related to symbolic operators, symbolic operators, etc. We will try to do that tomorrow. If there are any clarifications required today, you may please ask now. So otherwise, I'm stopping. Okay, thank you very much for your patient listening. Let me stop the presentation. If there is any question, you may please ask. Thank you.
Sir, can I ask one question?
Sorry, is there any question?
Yes, sir.
Yeah.
Can I have one question?
Yes, yes.
So that range, that variable, like suppose, can we have that range increment? Can it be a decimal point?
No, it cannot be.
So it should always.
No, range cannot be a decimal point. For that, we need to use another equivalent version available in the numerical Python library, which we will be discussing in the next, not in the next session, maybe the session after that. Range cannot have any non-integer increments.
Okay.
It's not possible as per the structure of that range. It's not possible.
Okay, sir. Thank you.
Okay,
Thank you very much, sir.
Thank you.
Is there any questions? I I think we can wind up here, sir.
Okay, so we will meet once again
Thank
tomorrow.
you very much for your fruitful session, and I hope it is very useful to participants. Thank you, sir.
So tomorrow at 6 o'clock once again, right?
Yeah, yes,
Okay.
tomorrow.
Okay. Thank you very much. We'll meet tomorrow. Bye. Good night.
Thanks, sir. Good night, sir.